In this video, we are going to discuss about the low frequency analysis of bipolar junction transistor. So, on the completion of this topic, the students will be able to acquire the knowledge and working principle. They can obtain the characteristics. They can know the knowledge of the characteristics and the basic applications of bipolar junction transistor and field effect transistor. And also, they can apply the knowledge gained in the design of transistorized circuits, amplifiers, and oscillators. Low frequency analysis of bipolar junction transistor. So here we have considered the voltage divider bias circuit, that is R1, R2, and the coupling capacitor RE. So you can find that is, since we are taking the RC coupled common emitter amplifier, we have bypassed the capacitor in this resistor region. So C1, C2 are the capacitors which we are using as C1 as an input capacitor and C2 is the output capacitor. So this will block the ADC component and allows the AC signal for amplification. And here we have considered the common emitter amplifier. So the emitter region will be grounded and the collector region will be the output and the input region will be the base. From the above figure, you can find out that there is 3 RC networks which affects the gain as its frequency, and it also reduces the below midband range. So here this RC network which is formed by the input coupling capacitor and the input impedance, and the RC network which is formed by the output coupling capacitor C2 and the resistance which is looking into the collector and the load resistance, and the third one is the RC network which is formed by the emitter bypass capacitor CE and resistance looking at in the in the input RC network. The following figure shows that the input RC network formed by the C1 and the input impedance of the amplifier. So here you can find out the resistance value, that is R in is equal to R1 parallel R2. So from this equation, that is V out, that is nothing but voltage divider things, that is R in is equal to R1 parallel R2 parallel R in. While you are applying the voltage divider rule, you will be calculating that is V out is equal to R in divided by root of R in square plus XC1 square into V1. So we know the value of these things, that is R in divided by root of R in square plus XC1 square equal to 0.707, which is nothing but 1 divided by root 2. So overall gain, if you are calculating, which is reduce the attenuation level, so here which provides the input RC network. So the reduction in this overall gain, we are calculating AV is equal to 20 log V out divided by V in, which is nothing but, we know that is output voltage by input voltage is nothing but 0.707, which is nothing but 1 divided by root 2. So you can write this equation as 20 log 0.707, which is nothing but minus 3 dB. So the frequency at this condition, that is we have the bandwidth level. So if we are getting the frequency, that is the frequency response will be getting from lower to higher, then we'll be getting a constant value, then again it decreases. So from the constant value minus 3 dB is calculated, and from that we will be finding out the lower critical frequency as well as the higher critical frequency. So if the resistance of this input source, if you are taking into account, this equation becomes, that is theta is equal to tan inverse of XC1 divided by Rn, and also this phase angle of this input RC circuit we are expressing as FC is equal to 1 divided by 2 pi into Rn into C1. So we know that it is resistance, input resistance which contains the input resistor as well as the input impedance. So we are writing as Rn is equal to R1 parallel R2 parallel HIE. So we know that is F is equal to 1 divided by 2 pi into Rn into C. So Rn is nothing but Rs plus Rn. So you are writing this equation as 1 divided by 2 pi into R1 parallel R2 parallel HE into C1. And while considering the bypass network, so the resistance that is looking at the emitter, we are following as R is equal to VB divided by beta into IB plus HIE divided by beta. So from this you are writing the equation as, that is RTH plus HIE divided by beta. Since this Thevenin theorem, we can write it as IB into RTH. So where this RTH is equal to R1 parallel R2 parallel RS. So this is nothing but the Thevenin's equivalence resistance which is looking into the base of the transistor through this input. So here this bypass network we are considering as Fc is equal to 1 divided by 2 pi into R into C. So we know the value of R, which is nothing but HIE plus RTH divided by beta parallel to RA. So substitute the value, we will be getting this current source which is replaced by the voltage source is given here. So this FC becomes, that is 1 divided by 2 pi into HIE plus RTH divided by beta parallel to RE into CE. And the quiz questions on the low frequency analysis of BJT. First one is the change in frequency by a factor of which is equivalent to 1 active. And the second one is what is the ratio of the capacitive reactance to the input resistance of the input RC circuit of a single stage amplifier at the low frequency cutoff.